You crack an egg into a hot pan, and within seconds something weird starts happening. That clear, gooey liquid surrounding the yolk suddenly turns bright white and solid. One moment it's almost transparent, and the next it looks completely different, firmer, opaque, and ready to eat. It happens so fast that most of us never even stop to think about it. But have you ever wondered what's actually causing that change? Why do eggs turn white when cooked in the first place? Is it burning, hardening, or something else entirely? Today, we're breaking down the surprisingly fascinating science behind one of the most common things you see in the kitchen, right here, on History of Simple Things. To understand why eggs turn white, you first need to know what egg whites actually are. Despite the name, raw egg whites aren't white at all. They're mostly clear with a slightly yellow tint. That's because egg whites are made up of around 90% water and about 10% proteins. These proteins are dissolved and floating around freely while the egg is raw. Some of the main proteins inside egg whites include ovalbumin, ovotransferrin, and ovomucin. These proteins are incredibly tiny, and in their raw state they're folded into compact shapes. Because they're so small and neatly arranged, light can pass through the liquid pretty easily. That's why raw egg whites look transparent instead of white. The yolk, meanwhile, contains fats, vitamins, and pigments, which is why it already has color before cooking. So the clear appearance of raw egg whites is really just a result of water and invisible proteins peacefully floating around together. But heat changes everything. When you cook an egg, the heat begins attacking those tightly folded proteins. Proteins are basically long chains of molecules twisted into very specific shapes. Think of them like tiny balls of tangled string. Their shape matters because it determines how they behave. As temperature rises, those proteins start to unravel. Scientists call this process denaturation. Once the proteins unfold, they can no longer stay separate from each other. Instead, they begin bonding together into a giant interconnected network. Imagine thousands of microscopic strings suddenly hooking onto one another and trapping water between them. That's what turns the liquid egg white into a solid. And this transformation starts surprisingly early. Some egg proteins begin changing at around 60 degrees Celsius. Different proteins react at different temperatures, which is why eggs gradually firm up instead of instantly becoming rubbery. The longer and hotter you cook the egg, the tighter this protein network becomes. That's why soft-boiled eggs, fried eggs, and hard-boiled eggs all have completely different textures, even though they're made from the same ingredients. The big question is this: why white specifically? The answer has to do with light. When the proteins are still folded up and floating separately in raw egg whites, light passes through fairly easily. But once the proteins unravel and clump together, they create countless tiny solid particles spread throughout the egg. These particles scatter light in all directions. Instead of light traveling straight through the egg white, it bounces around randomly, making the egg appear opaque and white to our eyes. Snow works in a similar way. Ice itself is actually fairly transparent, but packed snow looks white because all the tiny ice crystals scatter light everywhere. Clouds do the same thing with water droplets. So cooked egg whites aren't white because they contain white pigment. They're white because their structure changes how light moves through them. It's basically edible physics. If you've ever left eggs on the stove too long, you've probably noticed they can become tough, dry, and rubbery. That happens because the protein network keeps tightening as more heat is added. At first, the proteins gently connect and hold moisture inside, but excessive heat squeezes more and more water out of the structure. The proteins pull tightly together, creating that chewy texture nobody really wants in scrambled eggs. This is why chefs are obsessed with temperature control when cooking eggs. Even a small difference in heat can completely change the final texture. Low and slow cooking creates softer, creamier eggs because the proteins bond more gently. High heat creates firmer, drier eggs much faster. That's also why restaurant scrambled eggs often taste smoother than homemade ones. Professional cooks usually avoid blasting eggs with extreme heat. Interestingly, the yolk doesn't turn white when cooked because it contains a very different mix of substances. Egg yolks are packed with fats, cholesterol, vitamins, and natural pigments called carotenoids. These pigments come from the hen's diet and are responsible for the yellow or orange color. Even after cooking, those pigments remain. The yolk does become firmer as its proteins denature too, but the color stays mostly intact because the pigments continue absorbing and reflecting light differently than the egg white does. That's why a boiled egg ends up with a white exterior and a yellow center instead of turning into one giant white ball. Sometimes, hard-boiled eggs develop a weird greenish-gray ring around the yolk. It looks unpleasant, but it's usually harmless. This happens when eggs are overcooked. During prolonged heating, sulfur from the egg white reacts with iron from the yolk, forming iron sulfide at the surface where the two meet. That chemical reaction creates the green-gray color. It doesn't mean the egg is rotten, it just means it spent too much time in the heat. Cooling boiled eggs quickly after cooking helps reduce this reaction. So, the next time an egg turns white in the pan, you're actually watching a tiny scientific transformation happen in real time. Heat unravels the proteins connect into networks. Those networks scatter light, and suddenly, a transparent liquid becomes a solid white breakfast. It's chemistry, physics, and cooking all happening at once inside something most of us barely think about. And honestly, that's one of the coolest things about everyday life. Some of the most fascinating science isn't hidden in giant laboratories or expensive machines. Sometimes it's sitting right there in your frying pan beside the toast. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.